drive-in systems. Now remember what we said about forgetting everything you know about drive-in rack systems. Here's an all-new approach to pallet rail design. Look at this cross-section. This Ridgerack pallet rail is designed to take advantage of the laws of stress analysis like no other pallet rail on the market today. Others may look like it, but none can come close to performing like it. Watch this simple experiment. If we fold this piece of cardboard into a shape resembling a section of structural steel angle, and we support it on two supports simulating a simple beam system, we have created a crude replica of a common pallet rail system used in drive-in racks. Some people think this is the most substantial of all pallet rails. Now watch what happens when we apply a load like you would when you placed your pallet into the rack. It twists, but beams aren't meant to twist. They're supposed to deflect vertically. Twisting adds additional stresses to the rail, stresses which drastically reduce the rail's legitimate carrying capacity. But does it really matter in practice? We'll see in a moment. Ridgerack engineers recognize the limitations inherent in the rail designs produced by other storage rack companies. Their challenge was to design a rail that eliminated twist, but still did the things a pallet rail had to do: support and guide the pallets consistently and safely. The process took many months of investigation and testing. But success did come, and it culminated in a totally unique pallet rail, with carrying capacities far above those currently on the market. And best news of all, it cost less. Look at this comparison between a 3x3x3/16 structural angle rail and a new Ridgerack System 2000 rail. Not only does the angle rail hold far less load, it costs more because it uses a whole lot more steel in a less efficient way. Now look what happens in actual load testing. Here is a test apparatus designed to show comparatively the action of the two kinds of rails under identical loading conditions. On the left is a structural angle rail. On the right is a System 2000 rail by Ridgerack. Watch what happens as the loads are applied, as indicated by the position of the steel indicator rods welded to the bottom of each rail. At first, the rods simply extend horizontally outward. Then watch how the increase in loading causes deflection. The angle rail begins to twist, and continues to twist more as load is applied. The System 2000 rail shows absolutely no twist, and finally only deflects vertically downward as a beam should. No torsional shear stresses are induced, and no permanent distortion of the support ledge. Here is a great visual indication of the superiority of Ridgerack's design. And remember, I told you already that you can also save money while getting superior performance. The best of both worlds in System 2000 rails. As good as the rail is, you would certainly be justified in choosing Ridgerack. But there's still more. Look at this bolted support arm connection. 4 high-strength 1/2-inch bolts in closely tolerant precision bolt holes. The strongest connection on the market will simply not fail, ever. Its redundancy is incredible. You just can't apply enough load to this system to fail the bolts. And while we're on the subject of bolted connections, look at this monstrous top brace design. A huge stiffened lip channel of heavy gauge, high-strength steel, fully welded to end plates that create a high moment connection of unbeatable capacity. And just look at this connection. A flange that fully engages the lip of the upright column and 4 high-strength bolts, mounted in 2 different planes. This connection sets a standard for the industry. It's unparalleled. Some think it's overkill, but we know that it's the very core of our outstanding drive-in design, and it accounts for the extreme rigidity of our system. While we began our discussion at the floor, it is the very top that demands the most scrutiny by the wise system buyer. Check it out. We're proud of this design, and we know it will give you a lasting, rigid, abuse-resistant structure.